Welcome back, friends. In the previous session, we started our discussion by discussing about the differences between ideal and non-ideal solution, and then later we moved our discussion by discussing about the difference between ideal solution of positive and negative deviation. We solved some few examples, and in this session we are going to continue with the solved examples in this topic of states of matter. So we are starting with this question. At a particular temperature, the vapor pressure of liquid E and F were 20 kilopascals and 15 kilopascals. At a particular temperature, is on the vapor pressure of liquid E and F. Question A. Draw the graph to show how vapor pressure of E in the mixture varies with its mole fraction. Vapor pressure of nini? E. Only E. So, hilo ndo swala kwanza. How vapor pressure of E varies with its mole fraction. Lakini B. On the same axis, draw the graph to show how the partial vapor pressure of F varies with the mole fraction. So kwanza utatakiwa uchore vapor pressure ya nani? Ya E. Then B, on the same axis, unachora vapor pressure nani? Ya F. Halafu C, add a third line to show how the total vapor pressure of the mixture varies with its composition. Hilo ni C. Na D, which of E and F has a higher boiling point? Explain your answer. Note that assume E and F show an ideal behavior or ideal solution. Again, kama unataka kupractice unaweza kujipractice mwenyewe, lakini kama hutaki sisi tunakuwa tunaendelea mbele. Vapor pressure tumepewa 20 na 15. So tukidraw hiyo graph, on part A tutadraw graph kama hiyo hapo. Hii ni how E varies with its mole fraction. The mole fraction of E starts from 0 to 1, and unaweza kuona kwamba huku inaanzia 0 inapanda mpaka kwenye 20. So if the mole fraction of E is equal to 0 and the pressure of E will be equal to 0, it obey roots law. Kwa hiyo tunachora ideal solution. Hii ndio part A. Unaona part A ya swali letu. Lakini in part B we are required to draw the variation of the partial pressure of F on the same axis. So in part B tutachora ile graph ya A, then tutaongeza nyingine ya F. So this will be the answer in part B. Unaona kwamba tumechora graph ya F, F imeanzia huku imekuja huku, ya E imeanzia huku imeenda hivi. Kwa graph zote mbili tumezichora kwenye axis moja. Hiyo ni part B. Part C requires us to draw the graph of total vapor pressure ambayo ita start from here to here. Kama umeangalia sessions za ideal solution, I hope itakuwa very easy kwa wewe kuelewa. So hiyo part C tunaongeza total pressure, tunaongeza part C, tunaongeza graph ya total pressure. Unaona hiyo part C, vapor pressure composition phase diagram for solution of liquid E and F. Part C tunakuwa tunaongeza kama hivyo. Part D sasa wameuliza which one are the higher boiling point? Which one? If vapor pressure yake ni 15, hii ni 20. Which one has the higher boiling point? Kama unavyojua vapor pressure varies in inverse proportion to the boiling point. Kwa hiyo tunavukuta solution ina vapor pressure kubwa. Ina vapor pressure kubwa, maana yake boiling point yake ni nini? Ni ndogo. So this has a higher boiling point. Vapor pressure ndogo, boiling point kubwa. Vapor pressure kubwa, boiling point ndogo. Hii hapa ina higher boiling point as compared to this. This has a higher boiling point. So liquid F has a higher boiling point than liquid E. Liquid F has a higher boiling point than liquid E. Since it exerts a low vapor pressure in the mixture, therefore it is less volatile. Lakini swali E walikuwa nasema draw a graph to show how the boiling point of a mixture of E and F varies with composition. Mark on your graph the boiling point of the pure liquid E. Pure liquid E. Kwa hiyo tukitaka kuchora hiyo temperature mole fraction phase diagram, hilo ni swali E. Lakini swali F wanasema draw on the same axis a curve which would enable you to work out the composition of vapor over the top of the boiling mixture. Label your two curves carefully to show which is which. Manake ulebo kuonyesha yupi ni vapor, yupi ni liquid. Kwa kwanza swali hii tulikuwa tumeulizwa, swali hii hapa tulikuwa tumeulizwa kwamba kwenye swali hii tumeulizwa draw a graph to show how the boiling point of a mixture of E and F varies with composition, mark on your graph the boiling point of pure liquid E. Hiyo ni swali E. Lakini swali F tumeambiwa on the same axis, draw on the same axis a curve which would enable you to work out the composition of the vapor over the top of the boiling mixture. Label your two curves carefully to show which is which. Wakati part G, explain how you would use your diagram or graph to work out composition of the curve over the top of the boiling mixture in which the mole fraction of both E and F in liquid was 0.5 moles. Kwa hiyo kwanza tukianza na swali E, swali hili lilikuwa linahitaji tuchore graph showing the boiling point of E and F against composition. Hii ndio graph yetu inaonyesha boiling point of E and F against composition. Boiling point of E and F against composition. Kwa hiyo graph yetu inakuwa inaonekana kama hivi, ina liquid E, ina liquid F, na hii ndio graph hiyo hapo ni liquid phase. So temperature of E is lower as compared to the temperature of F. Boiling point of F is larger as compared to the boiling point of E. Kwa tuna liquid E, tuna liquid F, then composition of liquid F starts from 0 to 1, composition of liquid E starts from 0 to 1. So hiyo ndo graph yetu. Lakini on the same axis tunatakiwa tuchore graph ya nini? Ya vapor phase. Tunatakiwa tuchore graph ya vapor phase ambayo ilikuwa swali F. So the temperature vapor composition phase diagram of the solution, temperature vapor composition phase diagram of the solution itakuwa inaonekana kama hivyo, ambapo tunakuwa tuna liquid phase na tunakuwa tuna vapor phase. Tunakuwa na liquid phase pamoja na vapor phase kwenye hiyo solution yetu. So unaona hii ni vapor phase, hii inakuwa nini? Ni liquid phase, temperature E, temperature F. So unaweza kaona, lakini kwenye swali hii tuliambiwa tuonyeshe tunawezaje tukapata sasa hizo concentration zenyewe. Tunawezaje? Hapo unaweza kaona kwamba tuna P tuna liquid hiyo hapa labda M. Huyo hapa labda unaona kwa mfano huyo hapa labda tukimboil tunapata vapor pale. Tukimcondense tunapata. So on explanation tutaanza when the liquid at M is boiled we get the vapor at Q. When condensed we get the liquid with composition P. So kwenye explanation, hizi explanation unaweza kuzipata kwa uzuri zaidi kama utatafuta notes hizi kwenye either kipaji hapo ambayo iko Play Store au kwa kudownload application yetu ya Dr. Mlelwa ambayo iko Play Store, utazipata kwa uzuri zaidi. So tunasema kwamba when the solution containing 0.5 mole of E and F at point M is boiled, the vapor will be formed at point Q, and the composition of the vapor at point Q is obtained at point P, where the composition of E in the vapor phase is higher than that of F. So hizi explanations zote tulielezea kwenye behavior of ideal solution on distillation. When a solution at point M is boiled, we get the vapor at point Q, which has composition at point P, higher in liquid E as compared to the, kwa huyo hapa na 0.5 ya F pamoja na E, lakini huyo hapa E atakuwa ameongezeka kuliko nani? Kuliko F. E atakuwa ameongezeka kuliko F. So hizo explanation unaweza kuzipata kwa uzuri kabisa kwenye nini? Kwenye notes. Lakini question number 2, explain how a mixture of methanol and water behave on fraction distillation. Methanol and water, the mixture of methanol and water. Now remember kwamba methanol yenyewe ni alcohol, lakini alcohol ndogo. Kwa hiyo approximately the boiling point of methanol and that of water, they can form just the ideal solution. So the mix of methanol and water is an ideal solution. Why? It is because they are not so much different. So it's an ideal solution. And the strength of bonds, methanol form hydrogen bonds, also water tend to form hydrogen bonds like methanol. So when the mixture is boiled or distilled, the vapor will be formed above the solution mixture containing more methanol than water. Why? It is because methanol has a lower boiling point as compared to water. So methanol is more volatile. When the vapor is condensed and distilled again, the composition of methanol increases in the vapor than water. So composition ya methanol itakuwa inaongezeka on successive distillation and condensation. So on successive distillation and condensation, pure methanol will be corrected at the distillate in the collecting duct, correcting flask, and pure water remain in the distillation flask as residual liquid. Hence, mixture of methanol and water can be separated into pure components by fractional distillation. Now consider an illustration by using boiling point composition curve of the mixture of methanol and water. Consider an illustration. Na illustration yetu ndo hii hapa ambayo inaonyesha boiling points pamoja na boiling point of water, temperature of methanol, point P tunapata R, S, T, Q. So explanation, tukichukua liquid at P, tukaboil, tutapata liquid at R, tukicondense tutapata S, tukaboil liquid at T, then to condense on a successive distillation or evaporation and condensation tutapata hizo pure components. Aya, from there sasa kuna maswali hapa ambayo ni ya root law. Sasa root law tuisha solve sana, tuisha solve maswali mengi. Kwa mfano na 10 grams of methanol gives an ideal solution when mixed with 50 grams of ethanol. If the vapor pressure of methanol and ethanol at the same temperature are here up and here up respectively, calculate partial vapor pressure exerted by each component in the mixture. Partial vapor pressure exerted by each component in the mixture. So tuisha solve sana. Utaanza utakalculate number of moles, utatumia root law, tulisha solve sana. Yani kama tungekuwa ni class ningekuambia usolve, at the end of the day ningekuja kuangalia wapi umekosea. Lakini kwa sababu ya learning method ambayo tunaitumia, so you can solve and then you will look for the answers. Kwa hiyo if you need the solution of this question, you can go and find the notes, but in case ili swali tumesha solve sana maswali kama haya, na majibu ya mwisho tuko tumeulizwa the vapor composition. Majibu ya mwisho ambayo ni vapor composition utapata kama hapo, vapor composition of ethanol itakuwa kama hiyo. Lakini kwa mfano pia ili swali la pili nao ni root law. Swali la pili, liquid benzene and toluene form an ideal solution at 333. The vapor pressure of pure benzene ni hapo, while that of pure toluene ni hapo. If a solution is prepared by mixing 2 moles of benzene and 3 moles of toluene, then what is the partial pressure of each component in the vapor phase in equilibrium with this solution? Asa hiyo ni very easy. Partial vapor pressure ni very easy kuweza kuipata. Ni very easy kuweza kuipata. Kiufupi tu nikwambie kwamba kwa hii part maswali mengi tayari tumesha ya solve kule nyuma. Tumesha solve hilo swali la 3 kwa mfano, at 20 degrees Celsius the vapor pressure of toluene ni hapo and the vapor pressure of benzene ni hapo. Equal chemical amount or equal number of moles of toluene and benzene are mixed and form an ideal solution. Calculate the mole fraction of benzene and toluene in the vapor in equilibrium with this solution. In equilibrium with this solution. Kwa hiyo hili swali haujapewa number of moles, lakini umeambiwa tu ni equal number of moles. So kama ni equal number of moles, that means mole fraction of benzene will be 0.5 and mole fraction of toluene is 0.5. Ukishajua mole fraction is 0.5 na 0.5, hilo swali linakuwa limeisha kwa namna hiyo hapo. Namna nyingine zote zinasovika kama kawaida. So unaweza ukaenda ukafuatilia notes hizi ili kuweza kupata hizo nani. Kwa hiyo hapa tumemaliza. I have another exercise book which nitakuja kuendeleza hii topic ya states of matter. Lakini kwa hapa tumeishia hapa. Tuendelee tu, tutaendelea na solved example mpaka pale tutakapoanza steam distillation. Kwa hiyo endelea tu kuangalia session za solved example. Steam distillation taanza sio muda mrefu.